To graph y equals negative 3 times 2 to the x, we start by graphing y equals 2 to the x. You know how to do that. You know what these points are. If you don't, well, I think you do. Okay. And if you don't, make sure you learn. Okay. So, what happens? Your y values are all going to be negative 3 times what they are for the 2 to the x function. Meaning that you're going to stretch this thing vertically by factor negative 3. Every point is going to flip over to the other side of the axis and become 3 times as far from the x-axis. So that this point is this far from the x-axis. You flip on the other side and you go that far 3 times and you have the new point. So you have an arrow from here down to here. It's a little hard to see the head of the arrow the way I sketched in the graph, and you have an arrow from here up to here. This arrow is 3 times as long as this one and on the other side of the axis. And you do that for every point, and you get the graph of y equals negative 3 times 2 to the x. Again, reflect each point, make it 3 times as far from the axis. Same as saying we stretch vertically by factor negative 3, and we should understand why we do that. To graph y equals 2 to the x minus 3 by contrast, well, what do we have? We got the graph of y equals 2 to the x. Now every y value, for given x, the y value that you get on this function is going to be 3 less than what you get here. This says take the 2 to the x value and subtract 3. What does that do on the graph? Well, that lowers the point by 3 units. So every point is going to shift downward 3 units. So that's a shift of negative 3. Now, I didn't draw this particularly accurate. That negative 3 looks a lot bigger than this negative 3. So you might want to try to sketch it with an accurate scale and see how it works out. Now, the thing that I'll mention here is that this graph, as you should understand, the 2 to the x graph, is asymptotic along the negative x-axis, asymptotic to the negative x-axis. If you shift the negative x-axis down 3 units, the graph is going to be asymptotic to that resulting line, and that's the line y equals negative 3. Okay? Now, we want to look at the graph of log base 2 of x plus 5 in sequence. We first graph log base 2 of x. Here's the graph. How do we get that graph? Well, log base 2 of x is the inverse function to the 2 to the x function, which means that we get these points. We can make a table. Reverse the columns of y equals 2 to the x table and graph that, and we get the graph of log base 2 of x. So reversing the columns, we get these points here that correspond to these points here. Then x has been replaced by x plus 5. Well, that should tell you immediately that you have a horizontal shift of negative 5. And if it doesn't, you need to review everything we've done about horizontal shifts. But it says that x has to be 5 units less to get the same value of y. That means that we have to have a horizontal shift of negative 5 units. And maybe you can digest this statement to understand why the horizontal shift is negative 5. Okay, that's better than just knowing the rule, but if you just know the rule, you know, if you replace x by x minus h, the graph shifts h units in the horizontal direction. Okay, to get x plus 5, you replace x by x minus h, where h is negative 5. X minus negative 5 is x plus 5. So anyhow, every point shifts 5 units horizontally, negative 5 units horizontally, to give you a new point. You put a curve through those new points and you have it. And you also note that if you take the x equals 0 line, which is the y-axis, the log base 2x graph is asymptotic to that axis. When you shift everything 5 units to the left, that axis becomes the line x equals negative 5. We shift that over 5 units. And that's our new vertical asymptote. So there we have it.